This lecture, we'll study the long short term memory or the LSTM cell in some detail. Within this cell, there are several neural networks, one of which is the forget gate. What is the function of the forget gate in this cell? Now that we've understood the advantages of long memory cells over the truncated BPTT in order to deal with vanishing and exploding gradients in a recurrent neural network, let's look at how long memory cells are set up. We've seen that the main idea behind long memory cells is that a single recurrent neuron holds more state and thus has more memory. Typically, we won't deal with a single neuron. Instead, we'll work with a memory cell, that is, a group of recurrent neurons which work together. So you can imagine that this box that you see on screen is a memory cell. The input to this memory cell, notice, is the input at the current time instance, that is x of t, the long term memory c of t minus 1, and short term memory h of t minus 1. Within this box, there are a bunch of different components, and each component serves a slightly different function. There are components which help you forget unimportant old memories, form important new memories, components to update long term and short term memory state, and calculate the output yt, that is, the output y at time instance t, that's the current time instance. If you forget about the innards of the long short term memory cell or the LSTM, the inputs to the cell and the outputs from the cell should be very familiar to you. There is no change here. The LSTM cell stores both long term and short term memory, and there is a special component within it which is responsible for updating long term state. Once the choice of what's going to be stored in the long term state is made, this is the component responsible for updating this and feeding it back to the input as needed. Similarly, there is a corresponding component that is used to update short-term state represented by h of t. This short-term state is also another input to this LSTM cell. So it's not just state, it's both long-term as well as short-term state. This memory cell has within it another component which calculates the output at any time instant. That is the y of t that has to be the output of this layer. And this y of t is also fed back to the input. This is the same component that exists in a basic RNN cell. This is not unique to the long short term memory cell. The previous two components that we saw for updating short term and long term memory were unique to the LSTM cell. There are also components within the LSTM cell to forget unimportant old memories and form important new memories. These components have to be smart enough to evaluate the incoming input, that is the present input, as well as the short term and long term state that is fed in to decide what is important and what can be discarded. We know these components exist and what job they actually perform within an LSTM cell. These components are actually four fully connected neural networks. So we use neural networks that exist within a memory cell in order to perform all these functions. The forget gate is a neural network which is responsible for looking at long term memory, the long term memory states that's stored within this cell, and determining what is important and what events need to be discarded. This controls which part of the long term memory should be erased. The main gate analyzes the current input x, the previous short term state, and then determines what the output of the current time instant should be. The main gate is what exists in the basic RNN cell as well. In the basic RNN cell, the main gate simply generates the output of this cell. But in the case of the LSTM cell, this main gate stores a part of its output in long term memory. The input gate controls which part of the input should be added to long term state. Finally, the output gate controls which parts of the long term state should be read and output at this particular time instant. All of these components are referred to as gates because they perform element wise multiplication of vectors. Each of these components also have additional gate controllers that are not shown on screen here. These gate controllers determine when these gates are turned on and off. The use of these LSTM cells as opposed to basic RNN cells completely changed how we could use recurrent neural networks. LSTM cells functioned exactly like the basic RNN cell, but the performance was far, far better. Their ability to parse and understand and work with long term patterns made them very useful for applications where we couldn't use RNNs before, such as long text sequences, time series data, and so on. LSTM cells are not the only long memory cells. There are other variants that exist today and which we can use. Peephole connections are one example. They are basically LSTM cells that store state for more than one period. The GRU cell is another commonly used cell. GRU stands for Gated Recurrent Unit. This, in fact, is a simplified LSTM which has far better performance. It stores just one state vector as opposed to a long term as well as a short term memory. In addition, it has fewer internal gates and neural networks, which makes its performance better. There are fewer operations carried out within the GRU, but it still holds long term memory, so it functions basically as an LSTM cell. The forget gate is responsible for managing the long term memory within the LSTM or the long short term memory cell. The forget gate looks at the memories stored for long term and decides which of these are unimportant and they need to be erased. The decision to erase memory is made by this forget gate.